So technically, this is the start of your second to last topic this year, which is on statistical models, otherwise known as statistics. You have one test on it, which is your mid-year exam, term 3, week 5, hence why I'm starting some teaching before term 3. I don't get to be flexible with that. In the first half of this topic, we're concerned with what are known as numerical variables. Can someone describe to me what a numerical variable is? It's freaking numbers, okay? This is important because numbers have an inherent order. So 1 is smaller than 2, 2 is smaller than 3, etc. You don't get a choice in the order of numbers. Unlike categorical variables, which have no order, like hair color. What are the different kind of things that I could have for hair color? Red? Brown? Is there an order to that? No, you don't get. You can decide however your graph is placed there. But if you graph hair color, it's meaningless because I could change the shape of that graph depending on where I put the hair colors, right? Whereas with numbers, small to big. Numbers, small to big on the y-axis. So, in relationships between two variables, so who here doesn't do science in year 12? Okay, so you'll need to remember back to the last time you did science. In relationships between two variables, there's usually an independent variable. At year 12, we also know that as the explanatory variable. It's the variable that causes or explains the changes in the other variable you're looking at. This is always drawn on the x-axis of a scatter plot. So can we please imagine that I'm doing an experiment, I'm making a range of paper planes. Some planes have really thin wings, some planes have really wide wings. I'm changing the size of the wings on purpose, and then I'm throwing them. So the independent variable in that context would be the size of the wings. That leads us to the idea of the dependent variable, also known as the response variable. It's the variable that changes because I changed the independent variable. This is always drawn on the y-axis of a scatter plot. So, thinking back to that example that I just said, I'm changing the size of the wings on purpose. What's going to change because the wings are narrower and wider if I throw them? The distance they fly, okay? The distance the plane flies is not going to decide how wide the wings are. That's never going to happen. It's going to be the other way around. If I make the wings really thin, they might not go very far. If I make them wider, they'll go a bit further. So you need to always think about the idea of independent and dependent variable because you need to draw them on the right axis. I'm going to leave that. Can you please get that down to there? There's a lot of fluff in this lesson, but when you actually do the exercise, there's no maths whatsoever. You're just telling me what the variables are or telling me how strong the relationship is. No maths whatsoever. So also remember this topic is in your exam as well. So finance in the exam, all that home loan stuff. This is in your exam. And then the final topic we do at the end of term 3 is in your exam. No shares, no algebra in your exam. Okay? All right, I'll move on. If you're a little behind on the note taking, that's fine. I'll leave that up. The relationship between two numerical variables is known as their correlation. If you're doing psychology this year, you may be discussing the term correlation. Correlation between two numerical variables is described with 5 main characteristics. So they are this. They're kind of self-explanatory, but I'm never going to go and just tell you to read the book. I want to teach it to you myself. So the direction of a correlation is how the dependent variable, the y-axis, acts while the independent variable increases. That's the direction of the correlation. This also happens to be the general direction that the points form in a scatter plot. So if I look at this one, which we call a positive direction, as I go across in x, which means that the x is increasing, what's happening to y? Is y increasing at the same time, or is it decreasing? Increasing. Because numbers, there's an inherent order to them. If I drew numbers on the x-axis, this is going to go larger, larger, larger from left to right. Sorry, I forgot that I'm recording on the iPad. It goes from small to large on the x-axis, and on the y-axis it goes from small to large. So a positive correlation is when x increases, y also increases. Negative correlation, negative direction, as x is increasing on this middle one, what is happening to the y variables for these dots? Is it increasing, decreasing, staying the same? Decreasing. If I look here at the last one where there's no correlation, is there any pattern to how the x and y is relating? No, it's random. So you would say no correlation if it looks random. Okay? So like I said, no maths here. You look at the dots. If the dots are forming up to the right, positive correlation. If the dots are forming down to the right, negative correlation, negative direction. If there's no pattern whatsoever, you say no correlation. Okay? Give you a couple of moments to get those little pictures down. If you remember that, if it's common sense, I'll leave you to decide. You get a cheat sheet for this test as well. One-sided, A4, handwritten. Linearity is pretty common sense, but I'm going to teach it anyway. So this is the second of 5 things that describe a correlation. If there's a correlation between two variables and they form a straight line, that describes its linearity. So do you agree that these dots here, could I trace a straight line through that? So you could say that's a linear correlation. The points form a straight line. Whereas these dots here, they're forming a curve, so you wouldn't call that linear. It's a curved line. So points do not form a straight line. You would call that a non-linear correlation. And you have a couple of moments to get that idea down. Once again, no maths. You're just describing what the points look like. Don't lose marks for this. Bit further now, we've talked about direction, linearity of a correlation. The next point out of the 5 is the strength of the correlation. If the data forms a pattern or a trend, so we've established the pattern or the trend is a linear going positively, the closeness of the points is the strength of the correlation. Do you agree that these points are very close to the trend? They're close to the line? So that would be a strong correlation. Could someone describe to me how I might draw a moderate correlation? What would I do with the dots? Would they be close, spread out more? But like super spread out? No? Moderate, like halfway or something. So still close, but not as close as the strong one. Okay? What would I do for the weakest? Or weak? But still sort of going around a line, but just far away. Okay? So It's still forming a trend, but it's just not super close. So strong, moderate, and weak. A few moments to get those three, or work it out in your head how common sense that is. The next one is not so common sense, so if you wanted to minimize the things that you're getting down, outliers is an important one. All right, unless you've done science recently, you might not have talked about outliers recently. What is an outlier? So if the data points lie away from the main pattern or trend, we say that there's outliers in the data. Do I have a bunch of data at the bottom left here? Are there data points down?
Yes.
Yep. Is that pretty strong? Is it forming sort of a diagonal line going up to the right? So the main trend of the data is a line going up to the right. Now, some people in the past have told me that this is an outlier. Is it lying away from the main trend? No. It's on the trend. It's just further away. Okay? So that is not an outlier. It's on the trend. This is an outlier because is that on the trend? No. Is there another outlier there? Yeah. So you could say that this outlier is well below what we expected for the trend. This one is well above where we expected for the trend. That's an outlier too. However, this is not an outlier. It sits where we expected it to be. Okay? So I'll give you a bit longer to get this one. There's more to this. The last one about causality, not much to it. We can have a bit of a laugh because I'll go online and see what causality and correlation is about. All right, so the last point I want to make here, and as you can see, no maths yet. You're just describing the freaking dots. The last one is about causality. Please note that everything that we just spoke about here is about the idea of correlation. What does correlation mean? It just means that we observe one variable changing as another changes. We cannot assume that the independent variable is the main reason or the sole reason for changes in the dependent variable. It's just an assumption. If you can reasonably argue that the independent variable would at least partly affect the dependent variable, then we can claim a causal relationship between them. Please don't say causal. Causal. Causal relationship is, it's like friends with benefits, that sort of thing, right? Causal is when you have a relationship between two variables and one causes the other. So is it fair to argue that if I exercise, there'll be weight loss? Yes or no?
Yes.
Is that the only factor though?
No.
Would your genetics be a factor?
Yes.
But could we argue that the exercise causes at least some of the weight loss?
Yes.
Right? What's another part? The food that you eat as well. Yeah, see? Let's say if I was to visit some of these spurious correlations here, I'll come back to this screen after. I just want to get to the funny bit. There's literally a guy that compiled a bunch of spurious correlations with actual data. So you can see a pretty close relationship between the number of movies Margot Robbie has appeared in and the number of firefighters in South Dakota. Now, if you just ignored the idea that that's a correlation, that would suggest that the number of movies Margot Robbie's in causes people to apply to be a firefighter in this particular state in the United States. No, that's BS. Okay? That's just a coinky-dink or a coincidence, all right? Next one. US household spending on home maintenance, the average number of comments on technology connections in YouTube videos. That one's actually, you could argue that. Like there's something to that. Air pollution in Iowa, number of library technicians in Iowa. What I'm trying to get at is that, yes, these might be strong correlations, but there's not really causation there. Okay? There's a famous one, though, which is, I think it was around 2006. Researchers actually did a study in the state of New York in America, and they found that it was almost a 1-to-1 correlation between ice cream sales and murder rates in the city. Enough that people in the rich part of the city did like a what's it called? What is it when you get all the opinions of people and then send it to like a survey or something? Petition, sorry. They did a petition to try to ban ice cream sales in the city, right? That's 1-to-1. Ice cream must cause homicide. No, there's a hidden correlation there. The hidden correlation was that what would happen to the ice cream sales if it's hotter weather? More? And then there's another statistic that finds that what happens to the murder rate when it's hotter weather? You wouldn't know, but it's higher, okay? It's almost 1-to-1. That explains it. Because they just happen to be two separate correlations that happen at the same time, and it explains why the ice cream sales also goes up when the murder rate goes up, okay? Sometimes it's hidden. So you just need to keep that in mind when you're dealing with this topic that we're doing. So yes, just keep in mind that we're not talking about, it's not always causal, but if you can argue that it is, then you can make that assumption. Your homework, and now please, I don't suggest you have to do that now. If it's fresh in your mind and you want to get out the way, you could do exercise 4B, but you could do that in the holidays as well. Make sure you've done your timeline to the end of 8E, if not done already. Please continue your DI work and continue your test revision. I'll stop the video now.